Students. Hi students, this is Mrs. Allen, and we are discussing hyperbolic functions. And our objectives are to develop properties of hyperbolic functions, differentiate and integrate hyperbolic functions, and develop properties of inverse hyperbolic functions, and differentiate and integrate inverse hyperbolic functions. So as we spend some time looking at graphs, and I think that I'd probably do a nice Google search of hyperbolic functions and their graphs, and their origin and how they're related to the hyperbola x squared minus y squared is equal to 1, just to kind of see what everything looks like, because hyperbolic functions are really based in the exponential functions. So what we're going to do is go over some problems here today, and I'm going to go through it rather quickly. So if you have to slow the pace down or slow the speed down, you can, and go over it, rewind if you need to. So in the first part, we are, and I also give you a formula sheet for hyperbolic functions, so you have that. I'll try to send that along with this video. So we want to use definitions of hyperbolic trigonometric functions and inverse hyperbolic functions and evaluate each function if the value is not a rational number, then round your answer to 3 decimal places. So you can see the first problem that we have cosh. This is the hyperbolic cosh, which is cosh x is equal to e to the x plus e to the negative x over 2. So what we're going to do here, if we have cosh 0, then we're going to replace x with 0. So we get e to the 0 plus e to the negative 0. By the way, negative 0 is still 0 over 2. So you end up with 1 plus 1 over 2, which is going to end up equaling 1. So the hyperbolic cosh of 0 is 1. Then we have the hyperbolic secant, and you can refer to your formula sheet, but that is the reciprocal of the cosh. So you can see that what I did is I just flipped it. If you look over here and see how it's 2 over e to the x, I'm just going to put a 1 in here and here. So then I end up, I'm going to use a calculator with this, because you're going to end up with 2. It's like this. You're going to have 2 over e plus 1 over e. And you can actually simplify this complex fraction, but I'm just going to say, for sake of what we're doing, we're just going to say that's 0.648. Okay, so we get our answer right here. Okay, then in addition to that, you were looking at the fact that you have inputs and outputs, so they are ordered pairs on the graph of each of these functions that we're talking about. Okay, then you have hyperbolic cosecant here. So again, here's the sign. So the hyperbolic sign is the reciprocal of the hyperbolic cosecant. So in this, if I want to know what the hyperbolic cosecant of ln of 2 is, then I'm going to use this formula here, and then I'm going to put ln of 2 in for x. So I get 2. So I get the hyperbolic cosine, I'm trying to think, I'll put it down here. The hyperbolic cosine of ln of 2 then is equal to 2, and that's over e to the ln of 2, and then it's minus e to the negative ln of 2. So then that's going to be equal to 2 over 2 minus 1/2, which this is going to turn out to be 4/3. And I'm going to leave it up to you to check that out if you would like to. So the answer, hyperbolic cosecant of ln of 2, is just 4/3. Okay. And then we have the inverse hyperbolic sine. So that is what it looks like. The hyperbolic inverse of sine is that function. So it is an ln. As you could guess, that e to the x is the inverse of ln of x. So you could picture that there's some kind of ln involved here. So we have the hyperbolic sine inverse of 0. So we get ln of 0 plus the square root of 0 squared plus 1. And so that's going to give us an ln of 1 on this side, which is just going to be equal to 0. So our answer here is equal to 0. Boop. And when you look at the graph, it kind of reminds you of a lot, the hyperbolic cosine looks like a parabola kind of, and the hyperbolic sine looks more like a, so you're doing the inverse of the hyperbolic sine here, and you have the point 0, 0. So if you think of the inverse as you switch x and y's, but the hyperbolic sine looks kind of like a cubic, if you will, but it's not a cubic. So let's move on. We have the hyperbolic tangent then is 1/2 ln of the quantity 1 plus x over 1 minus x. Keep in mind, if you're taking the ln, then that has to be a number that's greater than 0 here. So with that one, we're just going to plug in 0. We have the hyperbolic tangent inverse of 0 is 1/2 ln, and then I'm just going to put 1 plus 0 over 1 minus 0. And we get that, and we calculate that as 1/2 times ln of 1. So that's going to turn out to be 1/2 times 0, which is, of course, 0. So again, we have 0 for another answer. Yeah, so if you don't know the answer, just put 0. Hyperbolic cosecant inverse, though, we have this is hyperbolic cosecant inverse of 2 is what we want. So there's the formula above in the first line. And the second line, I have hyperbolic cosecant inverse of 2 is equal to 1 ln of 1 over 2 plus the square root of 1 plus 2 squared is 4. So I'm going to put the 4 in there, and then this is over the absolute value of 2, which you don't need the absolute value there. So you get this is equal to ln of 1 plus square root of 5 and over 2, same denominator of 2. So we have that, which is approximately 0.481. So just calculating with these weird functions, right? So, all right, there we go. There it is. There you go. Okay, so now in this next one, you're dealing with identities. So on the sheet that I gave you with the hyperbolic identities, I have them written above. So A, remember that the hyperbolic cotangent squared is equal to that, putting the parentheses around the hyperbolic cotangent and then squaring is that weird thing about the superscripted, where does it go? And so you have to remember that when you're calculating, it kind of comes in handy to rewrite it like so. And then with the B up above, the hyperbolic cotangent is equal to the hyperbolic cosine over the hyperbolic sine. And then the hyperbolic for C, the hyperbolic cosecant is then equal to 1 over the hyperbolic sine. So now what I'm going to do is I want to verify this identity. So I take and I say, okay, the hyperbolic cotangent is in step 1. I'm going to change that to the cosine over sine, the hyperbolic cosine over the hyperbolic sine. And then the hyperbolic cosecant, I change that to 1 over the hyperbolic sine. And then I'm going to square both of those. And if you notice in step 2, then I'm going to write the expression in exponential functions. And I'm going to go ahead and simplify that then. Okay, and then I also do the same thing with 1 over sine. All right, so then what I get is the following. I get the top is going to be squared, but inside of here, these 2's can cancel, right? So you're just left with e to the x plus e to the negative x, and that's going to be squared, and that's going to be over e to the x minus e to the negative x, quantity squared. Okay, so those are both going to be squared. And then that's going to be minus 4 over, and you see the denominator is the same, so that's kind of nice, e to the x, losing my pen there, e to the x minus e to the negative x squared. Okay, so now that's equal to, sorry, got to go back here. This is equal to 1. There, this is equal to 1. So this is equal to 1, okay? So now I'm going to go over here, and I'm going to do some squaring and simplifying, right? So I get the following in the top. I get e to the 2x. I'm going to square this. I don't know if I want to square the denominator, but I might. Sometimes I just leave it in factored form. So I get e to the 2x plus 2e to the x, e to the negative x, plus e to the negative 2x, okay? And then I have the minus 4 that I'm going to tack on, okay? So I have the same denominator. I can bring these together. Okay, now remember, the right-hand side of this equation is still going to be 1. Do I want to multiply this out? I think not. I think I'm going to leave it as e to the x in the denominator minus e to the negative x squared, and then let's put the equal to 1 there on that side. So now remember, this quantity I'm going to highlight in 1 second here is right here. This is going to be just 2 because e to the x times e to the negative x is just 1. So let me see how I want to write this. I think I'm going to combine that plus 2 and a minus 4, and I'm going to get a minus 2. So I'm going to write this as e to the 2x plus e to the negative 2x minus 2 over, and look at the denominator. Now it's time. I think what I'm going to do is square the denominator. So what do I get when I square my denominator? And you can prove this yourself, is e to the 2x minus 2 plus e to the negative 2x. You get, because see that minus 4 when it combined, it did this so beautifully. You get this. Okay, now I reordered that's what you get. And that's equal to 1. And you know what we say? Yeah, look at the same thing over itself. 1 is equal to 1. Therefore, QED, quite easily done. We have proved it. Da, da, da. All right, so there we go. Now we have one more I want to do. It's called the hyperbolic. And you can review these if you want. I'm going to do this one more, maybe two more. And then I've got to go to a second video. So for this one, I've got e to the x plus e to the negative x is my cosh, right? So now when I'm looking at this, I'm thinking, oh, wait a minute. I am working with this expression over here, and I want to prove that it's equal to the cosh of 2x. So I'm looking at the more complicated side and changing it, and I want it to end up to be cosh of 2x. So here we go. So the first line that I have is I change to the e to the x expressions. Okay, then I'm going to square them. So on this step, so I'm squaring them by showing the product there, and you can see that I get a denominator of 4 in the back. So essentially, let's multiply the first two I get, and I'm going to simplify this because we just finished multiplying like this. So this is going to be an e to the 2x. Remember, you're just going to FOIL and go through that, right? So I'm going to multiply straight across the top. E to the 2x plus e to the 2x minus 2. Okay, now I'm going to let you verify that because we just did it. The denominator is 4, right? And then I have plus, this is going to be e to the 2x plus e to the negative, oh, I forgot the negative sign there, negative 2x, and then that's going to be minus 2. Oh, yep, hold on a second. Little error here. 2 minus 2. I have a plus 2 here. Sorry about that. So over here, I have a minus 2, okay? And then that's over 4. Okay, now I'm going to bring everything together. So what does it appear that I have here? Okay, well, I have 2. This is 2e to the 2x plus 2e to the negative 2x. Plus the 2's are going to cancel. We have a plus 2 and minus 2. And then that's all over 4. If we factor out a 2, we get e to the 2x plus e to the negative 2x, and that's over 4. Take 2 into 4, that's 2 times. So we get that this is equal to, I'm going to bring it to right down here. Well, no, let me leave it over here. So we get this expression, e to the 2x plus e to the negative 2x. But the thing about it is, it's over 2. It looks very much like the hyperbolic cosine. So which is equal to, but it's the hyperbolic cosine of not x, but 2x. So there we have it. That is what we wanted to prove, okay? So we would probably do this, e to the x plus e to the 2x plus e to the negative 2x over 2 is then equal to cosh of 2x. Boom, you're done, okay? So that one's done, okay? Now let me see if I have time for these. They're a little bit quicker. Now we move into the derivatives of the hyperbolics. So you can see what I have written if you need to pause the video because I'm going to move pretty quickly with this. So find the derivative of the function. Y is the hyperbolic cosine of 3x. Now, you have a chain rule here because if I highlight the inside function, it's 3x. You have to use u is equal to 3x and dx is equal to 3. So you're going to have to multiply. So we end up with the derivative up to the side here is negative cosecant squared. So what I'm going to do is say, okay, then it's negative the hyperbolic cosecant squared of not x, but 3x. And then it's going to be times 3. So the only thing you would do for your final answer is you would just write that as negative 3. Oh, just got to tap on this to get it to move up. So then that's going to be just negative 3 hyperbolic cosine h squared of the quantity 3x. And there you have it. That's your derivative. Okay? So now remember that cosh is always positive, right? So, or, I'm sorry, the derivative of cosh is, and the derivative of cosh is sinh, right? We call that the sinh right here. So, and so if I'm looking at the slope for this, it's always going to be positive, okay? I'm sorry, not the slope. Cosh is positive. The derivative is sinh. So now when I look at this, I'm going to use chain rule again because the inside function is cosh. Okay, so here we go. So y prime is equal to 1 over u. Our u, this is just like the logarithm derivatives we've been working on. Cosh, the hyperbolic cosh, hyperbolic cosh. Now, the derivative of u, du dx, if you will, is the sinh, right? So you just multiply the 1 over cosh, 1 over u times du dx, so you get the hyperbolic sine. Now, you know that that's equal to the hyperbolic sine over the hyperbolic cosine, which is the hyperbolic tan. And there's your identity. So you want to make sure that you know this. The sine over cosine, it's the same way. It's the hyperbolic tangent. And just familiarize yourself with the list of formulas, identities there, okay? Oh, come on. Here. Okay, let's try one more. This is going to use the product rule, and you can't forget you got to take your derivative of the sinh as well. So the derivative of x cosh, right? So we start off, we say dy dx is equal to, first, der second is going to be the sinh, minus the second, cosh, times the derivative of the first would be 1. Okay, and then we have minus the derivative of sinh is going to be the cosh. So you can kind of see that these two are going to cancel each other, right? So you end up with simply dy dx is equal to x times the hyperbolic sine. Okay? All right, I'm going to take a break because the video is getting a little bit long here, and I'll pick up with a second video. So this is hyperbolic trigonometry. And this is Alan signing out, and I'll pick up on the next video. Thanks.